I want to welcome everybody today. My name is Dr. Tony Ruocco. I'm from Roger Williams University in Bristol, Rhode Island. Going to talk a little bit about today on a course I created called Secure Programming. We use Ada and Spark, and it's a third-year undergraduate course. The idea of security in undergraduate education isn't new. We've usually, though, pushed that off to some sort of network-oriented course. But then in 2018, ABET added a specific requirement for principles and practices for secure computing. But we still generally said, you know what, we have our network security course. That's fine. So we've met that. That was a no-cost meeting. The problem with that is when you look at network security courses tend to look at secure programming and secure computing as something that the network server has to deal with. It's the operating system responsibility. So basically, a lot of computer science majors say, okay, yeah, I took my network courses, but that's it. It's kind of what's happening from box to box. Some other common things that I've been noticing is when you talk to computer scientists, even, there's just generally things, and we hear this every day. There's an app for that. If you're writing a program, find a library that has that code already done. The ever popular Google it. And then now there's this growing family of courses where you program language X for discipline Y. I get 10 or 11 messages every day, learn R for data science. So they're all valid, but something that the computer science majors need to understand is that what makes those kinds of approaches valid, that, yeah, find a library, find the app, is someone had to code those things. And if you're just blindly using these things that you find online, things that other people give you, things that are like, okay, you took this 14-hour canned lesson, you now can code. They have to understand they're the creators. They're not just advanced users of these kinds of tools. Again, some more general thoughts is the computer science majors have to be creators. They are creating the things that make it convenient for others to do things that we consider now to be everyday. There's far more to good code than getting it to work. There's still a lot of students who have the attitude that it works, it runs. It runs, it works, that's fine. I hit the go button. And also what I wanted to do is I wanted to create this course that still meets the needs for box-to-box security. Computer scientists do need to understand some of the basics of network security. They don't need to be system administrators, but they still need to understand that there is a certain layer of security that goes between the boxes. But what I wanted them to do is look inside the box itself. How can you write programs that aren't susceptible to errors that your network administrator let in by mistake? So again, you just can't leave it at that box-to-box level that's starting to become kind of an afterthought. The course I created is called Secure Programming. Some basic principles of security, common security flaws, and we say, well, everybody knows that. Well, if everybody knows that, why do we still have the same security issues that we've had in the 1980s, nearly 40 years later? One of the nice things about the course is the interaction between security, usability, and availability. And then how secure software and secure programming actually begins at the development process and the methodologies that we use in developing our software in the first place. We look at how to specify program behavior, known defects in your code. You can have code that under certain circumstances, you know they won't work. But there's also certain known defects that are inherent in certain languages. And we do talk about that in the course. We'll see it in a couple of other examples. But, what happens with when you're using C and half your algorithms start at n-1, go from 0 to n-1, and the other half go from 1 to n, and then you do all the subtraction. So all the things that you have to do to deal with arrays. We do use Ada and Spark, but even though I use Ada and Spark to do defect-free software, this is not an Ada as a second language type course. So I'm not teaching everything there is to know about Ada. We're not making them Ada experts or Spark experts by any sense of the word, but I do like it as a language for dealing with secure programming because of a lot of the features that it has. And that's what I'm going to talk a little bit about more today. And then talk about developing test cases, because a lot of students still don't understand that you don't test to see what works. You have to test to see what fails. My next set of slides is going to focus specifically on why I selected Ada. When I was creating the course, we have to go through a course creation process where before you can offer a course, it has to be approved by the faculty. Not because they don't want us to teach things, but for me to teach this course, some other course had to come out of the program. So again, it does go through a process of selection. So I said I was going to use Ada. The dean was former military, and he was military during the 80s, 90s, when Ada was declared to no longer be the DoD required language. So he said, Ada's dead. Why are we teaching a course in Ada when Ada was dead? When I mentioned this and we talked to some of the older faculty, they all said no one uses Ada anymore. Some of our advisory board members, they work in the industry, they don't use Ada. So they ask why we want to teach Ada when no one is using it. The one that was really kind of interesting is from our younger faculty. They asked what Ada was. They had never even heard of it. And then the number one thing is, why not use a language that the students already know? Our students had Java. Why don't we teach the course in Java? Some of the students had C++. Why don't we teach the course in C++? One of the reasons I picked Ada was specifically because none of our current students know it. They don't carry forward the bad habits that they had in their previous language courses. So the bad habits that they developed in programming in Java, the bad coding habits that they developed in using C++, or bad habits that they had in C, suddenly didn't count anymore because Ada was brand new to them. So they didn't just say, well, this is how we've always done it. The other thing that I've noticed is that our computer science program is very small. So if you're in a course with a student as a freshman, you're going to be in your computer science courses with them as sophomores. You're going to be in your computer science courses with them as juniors. You're going to be with them in your computer science course as seniors. You know who the good programmers are. You know who the weak programmers are. You don't feel intimidated by the skills others have shown in other courses because they don't know the language either. So it's not like you're walking into your data structures course where you know everybody who got the A in Introduction to Programming and you got a C. That doesn't matter anymore. Everybody is on that same level playing field. There's no intimidation among the skill sets that you've seen in other people. I like Ada and Spark because it highlights other course outcomes. It's very easy to see connections between Ada, Spark, and security. You can account for issues with other languages without sounding like they are being bashed. For example, we always talk about what do you do with the 0 element in a C array? Do you load that to real data? Do you use it for some sort of counter? Suppose you use it as a counter, but somebody else working on some other aspect of the program is using it as a data element. So again, we can account for that in Ada, because if you want an array that goes from 2 to 5 or 2 to 20, you create your index that goes from 2 to 20, and you don't have to worry about, okay, for every index, subtract 2 to put it in the array. Are we subtracting 2 to put it in an array, or do we have to add 2 to take it out of the array to know what index element you're actually referencing? So there was a lot of nice benefits to having that level of control over the arrays and over different aspects of the language. I use Ada and Spark a lot in the course to show how we're overcoming issues with other languages, but you still don't want to make a student feel like, oh, I've done all my programming in Ada before this course, that I was using the wrong language. Oh, wow, how could I have been, so misled into thinking that Java or C++ was good when we're finding out all these issues with the language in the secure programming course? Well, the goal was to highlight all those errors in these languages, not because we're saying those languages are bad, but a language is a tool. You pick the tool that best serves your problem. So if you need a problem and C is a good language, then use C. Just be aware of what these other security issues are. So again, it's not that Ada is inherently a better language. It's better for security. It's better for certain applications. But, if you want to use another language, that's fine too. You can write secure coding in other languages. It's just that there's more you need to be aware of. My students themselves are predominantly computer science majors. They would be in either their 3rd or 4th year of the major. All of them would have had a programming course. Java is our language of choice. They would have had a data structures course. They would have had a programming languages course. Our current iterations of programming languages have been survey courses, not looking at the theoretical applications of language and semantics, but just these are some of the modern languages that are out there. This is how you use them. They would have had a course on a computer organization, a sophomore level type course. They would understand the CPUs. They would understand registers. They would have seen assembly language. They would have seen C. And many of them, depending on where they actually take the course, they would have had a course on operating systems, probably on compilers. They would have had a computational theory course. They may or may not have had a software design course. But over the last year, well, the course has only been run 3 years, but what we're starting to see is some of our cybersecurity majors are taking this course as well. They have experience in C and C++. Most of them have experience in JavaScript. So another nice reason for using Ada is if anybody comes in with languages that aren't the traditional programming course language, it's okay, because that, I don't want to say it doesn't matter, but it really doesn't matter because the other people in their course don't know Ada either. So again, you're taking people with a vast background and you're just saying, okay, we're now all at a level playing field. We've done the course 3 times now. What we do is by using the online tutorials, the students are really able to get up to an array of records, and there's very, very little instructor input. Basically, what I do is in the course, in the early part of the course, I introduce them to the online lessons, the online tutorials. And what I do is throughout the course, I give them certain checkpoints. Okay, by now you should have done these 3 tutorials. By now you should have done up to this point, up to this point, up to this point, so that when I'm really ready to use Ada within the course to start tying things together, I know where my students are. I'm available for them to help. One of the issues that I have noticed is if my students aren't paying attention, they can download different versions of the IDE, or if they use one of our labs, the labs have 2 or 3 different versions of the IDE. But the student version of the IDE, even though it looks the same as the tutorial versions of the IDE, there is a little bit of loss in translation. Certain things, the way it looks on the tutorial doesn't look the same on the student version, and they notice that. That was one of the things that I deal with mostly is, yeah, that's what the tutorial does. Just make these slight changes, it'll work for you, no big deal. The debugger, though, in the 3 iterations of the course, I don't think I had any student actually figure out how to do the debugger. One of the things they do is they revert to what I think is the absolute worst habit we teach our computer science freshmen is hit the compiler and let it find all your errors. I think we should be able to teach them to do a little bit better pre-testing. And then a lot of them reverted to the old school, do a printout. I got to line 35. I got to line 45. I got to line 75. I predate debuggers, so I'm very familiar with that. But one of the things you have to remind them of is take those comment lines out. There were a lot of submissions that students would provide me where halfway through the run, I would start seeing this output. Got to line 35, got to line 29, got to line 75, whatever it was that they were doing. So I thought that was kind of like just another way to teach the students. There's a lot of things you do in writing code that you don't want happen in executing code. And actually the debugging by printout was actually a good example of that. One thing that I found over the 3 iterations of the course is if anybody hasn't used Gnat Tracker, they are missing out on an amazing resource. I don't have an example with me right now, but I've asked some really strange questions about why very, very specific installations weren't working. And I was getting responses within 2 days. And that was amazing. And my students got very comfortable with asking about issues because they knew they would get a response quickly and they would not spend, a week in frustration knowing that an answer would come quickly and they would be able to work around some of the issues until they got resolved. One thing that I've noticed is our students don't understand how their C drive is organized. I have to walk them through the installation so that they know where the code is being loaded. They know that when they go to write a program, where they're going to be able to find it if they're just trying to do a search. And another thing that I've noticed is our students have developed the double click mentality. If they saw anything that ended in ADB or ADA, whatever the version was, they would just double click it. The IDE opens, they're able to make edits to their code, but the code doesn't run, and it doesn't compile if it needed different packages, because even though the IDE is open, it doesn't open up all the project links that happen when you open it up through the IDE. So I think that was one of the more interesting issues that I've had, is that they don't understand the IDE very well. It would be nice if we had the coverage and testing tools for demos by the instructor. I know that whenever we talk about coverage and testing, we always bump up against the halting problem. But that's a fun discussion too to have with students. But the thing is that the coverage and a lot of the testing tools are there in the IDE. They're grayed out. So the students did complain that the IDE was probably one of the more complex ones that they've come across. And there was a lot on it that they had no idea how to use because it was grayed out. So they don't know if they were supposed to use it or not. One of the nice things that they found in using Spark is all the things that Spark found in the code that was potential errors that they would have never considered looking for. And because of that, because Spark found all these errors, like, well, how do you know that the index, when you add something to the index, you're not going to go outside the bounds of the array? Or when you subtract from the index. So if you want to go from index I to index I minus 3, how do you know you haven't gone outside the lower bounds of the array? Students are very good at checking against the upper bounds. They are very poor at checking against the lower bounds. They never consider things that Spark found for them. How do you know you haven't exceeded max int? How do you know you haven't exceeded your maximum value of any given number? So again, things like that were really good in tying Ada and Spark back to larger issues in software design. And the thing is that these were inherent in the language. They're not inherent by looking outside the language in. They found a deeper understanding of the limits. What limits do you base on hardware? What limits do you base on software? One of the nice things that they got from Ada, or at least one of the nice things I think they get from Ada, is they finally understand the difference between compiling code, building code, and running code. Almost every IDE that you get in Introduction to Programming Language, you just hit the go button. Compiling is done automatically, building is done automatically, running is done automatically. And because they start seeing the difference between compiling and building, it allowed me to do different kinds of problems where I would give them packages and say, okay, I need you to write this package, and this package has to run with my existing code. And by the way, I'm not going to recompile any of the code that I already have written. So if you send in a submission and say, hey, I changed all your integers to float numbers, it's like, no, that's not going to work because I'm not rewriting all my code. You have to do that. So they got to see a lot of that software development, software design, understanding specifications, not just in the code kind of specifications, but also software design specifications. So that in my next iteration of the course, now that I've gotten a little bit better at understanding the capabilities of my students, we are going to write one program where each student has to write a separate package, and those packages all have to work together. So it's a little bit of individual work and group work at the same time, without anybody being able to hide in the group. I like to give them portions of code. I would run their submissions on my modules. I would run my modules on their submissions. Again, it gives that understanding of requirements, really important, of well-defined interfaces. The nicest thing that it did is it prevented large monolithic type programs. So many of the students would write one huge program with all the procedures embedded in it. They got the chance to see what it means to pull out procedures, as packages, being able to have other people write packages and incorporate them into their code. So they see a lot more of that software development, and it's a little bit easier to do in Ada than in some of the other languages, because Ada is just built for that. They saw a lot more modularity, a lot more portability of code. And again, one of the nice things about the whole course in general is Ada and Spark was used as a vehicle that showed security goes from the program level to the network level, and it's not just the NetSec issue. And I think because we're looking at that interaction between what's happening inside the box and the network level, we're getting a lot more cybersecurity majors to take the course as well. So from my perspective as a faculty member, my enrollment is increasing from people outside my major, and that's a big deal. Again, because no one knows Ada coming in, and because we talk about all the other languages not as being bad, but having issues they need to be aware of, and how Spark works to prevent those inherent in the language. So again, we'll talk about the array issue. In C, you have to deal with, how do you deal with S0? And Ada, you just make it go away. The language inherently allows you to build the arrays the way you want. Not that C is bad, not that Java is bad, but all these languages have their own issues. You pick a language based on the problem, and you also pick a language now because they're more aware of them. You also pick a language based on the risks of using one language over another. So it's no longer just what's easier to code, but they're moving from what's easier to code with to what's best to code with. And there's a lot more criteria than just, oh, I can make it run pretty easy. Again, it ties together a lot of the other areas. They got to see coherent, larger picture. Normally what happens is, most of us don't remember our undergraduate days, but basically you went to class, and then when you took your final exam and you got your final grade, it's like, okay, I'm done. I'm going to flush my memory buffer and move on to the next course. So what Ada did is it tied together a lot of information from a lot of other courses. So these courses are no longer just chunks of independent information. They're actually tied through a theme throughout the entire program. So I kind of like that idea as well. Now, the nice thing about Ada and the way the course is designed and the way Ada is used and all the nice things that Ada gives you is you can use Ada and still think, oh yeah, there's an app for that. We can use interfaces. Ada has libraries that you can use, so you can find the libraries that work. They still Google it, but that's, we're not going to get away from that. But at least now, when they start doing that, when they start saying, okay, let me find an app, let me find a library, let me Google it, that what they need to do is they are aware that they have to find where the diamonds are and not just that they got a truck full of coal. One other thing that I wanted to mention, and I didn't bring it up, I probably should have. One of the things that our students do, and I bring Spark into this, is our students are really good at using arrays that are full. So if you say sort an array of 1,000, sort of array of 1,000,000, it doesn't matter. They know how to sort that. They know how to load that array. If you really want to challenge a student, tell them you have an array of 1,000 elements, but you're not sure how many of them are valid. And what do they do? And when they ask, what kind of example would I give them? I give them, okay, we have a classroom. Our classroom has 32 seats. There's 18 students in the class. What am I doing with those other 12 seats? Here we know they're empty because we made them empty. When you're looking at an array of 32 elements in memory, each of those 32 elements of that array have a value. You need to determine if the value is valid. So again, it starts them to really think about not everything they've been used to seeing, but how do you deal with the situations they haven't seen before? And for those in the US, thank you for your time this morning. For those who are in Europe, thank you for your time this afternoon. Are there any questions?
I'm sure there will be some questions, but I can start to get the ball rolling. It was really funny to hear about Ada as the unknown programming language as a way to put all students on an equal footing, because that's really runs contrary to what, for example, Claire said, that since students don't don't have prior knowledge in Ada or Spark, well, she needs to start the course, to spend a little time on putting them up to speed with Ada. So that's an interesting take on that. I don't know if you've seen it in other courses, this selection of language.
There's a couple of things there. I remember way back when Ada was the primary teaching language. So having students being unfamiliar with the language is not a big deal. I do rely on them coming into the course having some programming experience. So I don't have to teach concepts of loops. I don't have to teach concepts of the different data types. But I'll tell you, students really aren't used to a language which is as strongly typed as Ada. So I do have to tell them that 2 and 2.0 are not equal. But I like them not knowing the language, and I like the idea that I picked the language. I like Ada, so that was part of it. But I didn't want to have to say, okay, we're going to teach Java, and then worrying about how I'm going to teach Java to my C++ students. Or if I wanted to do C++, what do I do with the students who came in with Java? Technically, I could take this course, and if a person came in and only knew Fortran, they would be able to understand the concepts of the course. So that's,
you don't get pushback from students who would be kind of allergic to begin-end step of collaborations. Like we see sometimes some engineers, like in online chat and forums, who have very strong opinion on syntax. So does it occur with students, or are they still a bit more flexible than long-time programmers sometimes?
When it comes to things like that, I'm old. I think there's something
Me too.
fundamentally wrong where a typo in syntax, when you make a typo in syntax, you suddenly created a brand new variable and the program runs with it. And I still have a running battle with several faculty members who say that having to learn syntax detracts from problem solving. Syntax is part of the problem solving. You have to solve the right problem, and you need a language to solve the problem. It's not just getting something to run. So there is some syntax issues, but most of the students don't have a big problem with it. Where I do get a problem with using Ada is I've gotten calls from several parents who work in the technical fields of why am I teaching their students or their children an archaic language? And I tell them, well, it's not archaic. I'm teaching your son or daughter a language that they can use so they can get a job with NVIDIA as they convert all their vision software to Ada for autonomous vehicles. And that kind of tones them down from there. So, again, the biggest arguments I got from Ada generally are not the students, it's from the peripherals.
So please, if you have questions, so there will be a dedicated Q&A session at the end. Fabien, yes.
Yes. So first, I think that's just what you said is a very interesting comment about the parents. I have a good news for you, Anthony. You talked about the coverage analysis tool, and in fact, they will be available, and I will mention it later. But you should be able to use them in the future. So the GNAT coverage tool will be available very soon.
Oh, that's great. That's one of the nicest things we'd like to be able to show.